So this is a joint project with Mario Leccese, with at Boston University, and it's a lab experiment about multidimensional disclosure. Let me start by stating the obvious and saying that many economic interaction takes place under asymmetric information. There are many cases in which agents have to make choices without having a full knowledge of the payoff relevant variables in the environment. This problem is exacerbated when there is also interest misalignment between the informed and the uninformed agents that in this talk I will refer to as sender and receiver. Indeed, the willingness of the informed agents to exploit the information advantage can prevent the resolution of the asymmetries in the environment. However, there is a well-known theoretical result in economic theory that says that when communication has more friction and information is verifiable, the sender should be willing to voluntarily disclose all the information, resolving the asymmetry that there is between the parties. The intuition behind this result is very simple. When information is verifiable, the sender is unable to manipulate the information and can only decide whether to disclose it or not. If there is a group of senders with their private information deciding not to disclose it, they will face a receiver who will treat them at the same way and will consider the full distribution over the private information. This implies that the senders in the group that have the more favorable private information will be willing to separate from the group and show to the receiver their piece of private evidence. This trigger a downward adjustment of the receiver inference, and this process goes on until the receiver becomes maximally skeptical about the undisclosed information, and withholding any type of evidence becomes completely unprofitable for the sender. This implies that in this setting, communication is able to fully resolve the information asymmetries, and this result is referred to as information unraveling. There are several empirical papers that have tried to test this prediction, and they have focused both on the inference that the receiver makes, so on this process of pessimistic inference of the receiver, and on the behavior of the sender, so their disclosure incentives. In particular, Jean-Luc and Martin have a paper in which they study in the lab a game that is in the spirit of Milgram 1981 to verify whether unraveling actually happens. They find that when immediate feedback about the strategy of the opponents is not provided, unraveling is incomplete. There are two main reasons for the incompleteness of unraveling. First, the receivers end up being not skeptical enough about the undisclosed information. And second, the sender is able to exploit this naivete by optimally withholding information. The naivete of the receiver in this setting can be considered, is consistent with the inability of the receiver to perform the hypothetical reasoning that requires getting to this pessimistic inference that is required in the theoretical prediction. When receivers make their choices in the game, they need to think about the private information that the sender may have and the consequent strategic choices. Even if subjects deeply know that favorable information should be disclosed, they may fail to make this reasoning when they are presented with no evidence, so when the sender actually decides to withhold the information. In the paper that I just mentioned by Jean-Luc and Martin, the private information of the senders just consists of one piece of private information. So receivers can form belief about the strategic choices of the sender just by comparing the decision of the sender in a round with the decision that they made in the past rounds. As I was mentioning, it may be that feedback is not available, so the only thing that the receiver can do is thinking about what was done in the previous round of the game. However, this may make the strategic nature of the strategic choice not salient enough for the receiver to allow them to make this necessary hypothetical reasoning. In practice, though, there are many situations in which the relevant private information that senders have is instead multidimensional, and sender can decide to withhold some piece of information and to disclose some other one. So in these settings, senders have a more complicated choice to make, and they can decide both whether they want to disclose something, and if they want to disclose something, what they want to disclose. This may allow the receiver to have in front of them an immediately available comparison between different disclosure choices. And this may make more salient the strategic nature behind the disclosure decision of the sender. So what I mean with that is that reasoning of the types, if one attribute is disclosed and the other one is not, the latter must be worse, are much easier because they can really happen at the same time. If this is the case, in a game in which the sender can potentially selectively disclose, we should expect the receiver to be most pessimistic after no disclosure, and we should also expect the sender to disclose more as a response to this increase in skepticism. This dynamic is exactly what we want to study in this paper, where we ask as main question whether the dimensionality of the information space that the sender has can affect the outcome of the disclosure game. And in particular, we wonder whether this will lead to more disclosure and whether this will lead to more skepticism of the receiver about the information that is not disclosed. And then we want to investigate a little bit more the potential channel of a change in the outcome by studying whether this is due to a shift in the player's belief. And in particular, whether the change in the player belief is consistent with this improved receiver's ability in making the strategic choice that will lead to the optimal skepticism. Okay. I'm going to be quick on the literature in the interest of time. I just want to say that our paper relates, of course, to the literature of disclosure of verifiable information. There is a big theory literature and also a big empirical literature that focuses both on lab experiments and on field experiments. The other thing I would like to mention is that our paper is related to the literature of selection, neglect, and failure in contingent thinking, because we really think about this increase in the dimensionality of the information space of the sender as an aid that we can provide to receiver to improve their contingent thinking about all the possible actions that the sender may have taken in the game. Okay, let me just move to our theoretical framework. I'm going to be quick here because really our model is a simple application of the model by Milgrom, 1981. We have two players, a sender and a receiver. The sender is endowed with some private information that we will call as a type theta. And we're going to have two different games, a control game in which is more standard, in which this type theta is just a scalar. So it's going to be an integer from 1 to 5, with each of these realizations being equally laggy. And then we're going to have a treatment game in which we make this change of increasing the dimensionality of the information space, and we make the private information of the sender being a vector rather than a scalar. Each component of this vector that can have two components is going to be again an integer from 1 to 5. And this is important. Each realization of the vector is independently drawn. So the two components have no correlation between them. And they are again equally likely to be any number from 1 to 5. In the game, the sender can only verifiably disclose information about the type that in the experiment we will refer to as secret numbers. So sometimes in the talk, I'm also going to talk about secret numbers. This is the type in the model. In the control, the sender only has one scalar as type, so he can decide to either disclose it or not. In the treatment, instead, the strategies available to the sender are richer, and in particular, the sender can decide to disclose nothing, to disclose both secret numbers, or to disclose only one of them. We will refer to this case in which only one number is disclosed as partial disclosure. Given the choice that the sender takes, the receiver aims to correctly guess the type. So this means that in the control, the receiver will have to take one guess about the scalar theta, while in the treatment, the receiver will need to take two guesses, one about scalar theta 1 and one about theta 2. In both cases, we restrict the guesses of the receiver to be an integer from 1 to 5, and this will just be simplify the strategies available in the round. Finally, the payoff of the sender is increasing in the guesses taken by the receiver. So while the receiver wants to correctly guess the type, the sender might like to persuade the receiver to take actions that are as high as possible. So in this sense, there is misalignment of interest between the two players. Okay, so let me let me just tell you what are the theoretical prediction. The same argument as Milgram 1981 allow us to conclude that there is always a sequential equilibrium with full disclosure. The reasoning to get to this equilibrium is the same unraveling idea that I gave you in the introduction. And so the outcome of the game will make the receiver maximally skeptical about undisclosed information. It doesn't matter whether it comes from complete withholding of the information or partial disclosure, and will push the sender to be maximally skeptical about it, so to take the lowest possible action. Given this, the sender will strictly prefer to disclose every piece of information, except for the case in which the value of theta is actually equal to the lowest possible number. And so in that case, there will be indifference. I would like to mention that given the discreteness of the action space, we also have other sequential equilibria that could arise in this game, but they are all really fragile. I mean, most of them are really fragile and can be refined very easily. So we will mostly focus on this full disclosure equilibrium. Given the theoretical prediction and the results that we already have from the literature, and in particular from the paper by Jean-Luc and Martin, we derived three main testable hypotheses for the sender. First, we conjecture that moving from the case in which there is only one secret number that we will refer to as control, to the case in which there are two secret numbers that we refer to as treatment, the rates of disclosure of the sender will increase. So the sender will disclose more. Our second conjecture is about partial disclosure that, according to the theory, should never be used by the sender because it's never profitable. And so we conjecture that partial disclosure will account for a negligible share of the disclosure choices of the sender, and that should only be used when the private information is the lowest possible one. And finally, we have a conjecture about the sender's belief, and we want to test whether this belief about the receiver guesses after undisclosed information actually become more pessimistic in the treatment compared to the control to support our conjecture about the sender's behavior. Similarly, we derive two main testable hypotheses about the receiver. First, we conjecture that in their behavior, receivers will be more pessimistic in the treatment than in the control, meaning that they will make lower guesses for undisclosed information when two secret numbers are available. And we conjecture that this will be partially, mainly the case when there is partial disclosure. The second hypothesis about the receiver is again related to the receiver's belief. And we conjecture that the belief about senders' secret numbers when they are not disclosed will become more skeptical in the treatment than in the control, and that this will be true mainly in the case of partial disclosure. Let me spend a few words about our experimental design. I have really not much to say here because what we do is just implementing these two games that we just discussed in the lab. So we will have a control treatment in which the type is a scalar, just a secret number, and this will replicate one of the treatment of Jean-Luc and Martin. And then we have our main treatment in which we have two secret numbers. Players play in fixed role, we randomly rematch them, and we provide no feedback. The reason why we provide no feedback is because the fixed role and no feedback treatment in Jean-Luc and Martin is the one in which failure of unraveling are more likely to persist. So we really want to understand whether our intervention with the additional information dimension is able to restore, at least partially, disclosure even in this treatment without feedback. We use the same payoff structure as in Jean-Luc and Martin, and we show them in a table like they do. We have a between subject design. We run 4 sessions for the control and 6 sessions for the treatment. And we have a total of 60 subjects for each treatment. Players play 30 rounds of the main game, so this disclosure game that I just illustrated. And then they play additional 20 rounds in which there is again the disclosure game, but we also elicit belief. The way in which we elicit belief is slightly different from the previous literature. First of all, we make sure that the belief elicitation is incentivized, and to do so, we follow the binarized scoring rule. Then we make players play the same disclosure game that they played in the first 30 rounds. And we ask senders some question to state their belief about what the receiver's guesses will be after a certain disclosure decision. Similarly, we ask receiver what are their beliefs about sender secret numbers, given again some disclosure decision. What is different from the belief that have usually been elicited in the literature is that we directly ask questions about payoff relevant probabilities. In particular, for the receivers, we don't ask a question about sender strategy, but we ask directly a question about what you think the secret number is given this disclosure decision, or at least what's the probability that the secret number is equal to this value. This has the advantage that does not require to use Bayes' rule to back out these probabilities in the receiver's problem. Okay, let me start showing you some of the results. Remember, our first hypothesis about the sender was that the rate of disclosure increased in the treatment compared to the control. So in this figure, you can see reported with the darker bar the frequency of disclosure for each secret number, 1, 2, 3, 4, and 5. And in the, with the lighter bar, we report the frequency of disclosure of the same secret number in the treatment. In order to compute this measure in the treatment and to have it directly comparable with the control, we initially treat each secret number, even two secret numbers that are in the same pair, as an independent observation. And we really just compute how many times the sender decides to disclose that value of the secret number to the receiver. It's clear from the figure that for the unfavorable information, 1 and 2, there is a big increase of disclosure in the treatment compared to the control. This increase is only significant at the 10% level for the secret number equal to 1, but it's instead increasing significant at the 1% level for the secret number 2. For the more favorable information, so 3, 4, and 5, the rate of disclosure does not significantly differ in the two treatment. So we do validate our first conjecture that this manipulation of the information space leads the sender to disclose more. However, the figure I just showed you does not consider the fact that when taking a disclosure decision in the treatment, the sender accounts for the pair of number rather than for each secret number independently. It could be that the sender just decides whether to disclose a secret number or not as a function of the other one in the pair. So what we show in this figure accounts a little bit for this possibility, because for each secret number, we plot what's the probability of disclosure as a function of the other secret number in the pair. So for instance, in this first panel, we represent the probability of disclosing secret number 1 when the second secret number is 1, 2, 3, 4, and the same for every other realization of the secret number. It's very easy to see that for secret numbers equal to 1, 4, and 5, which are the more extreme both in terms of unfavorable and favorable information, the disclosure does not really depend on the value of the other number in the pair. This is not the case, though, for secret number 2 and 3. Indeed, in both these cases, we see that there is significantly more disclosure when the other number in the pair is different from 1. So when the other piece of information is different from the worst possible one. We will see in a moment that this is consistent with the player, with the sender's belief, and this dependency of the disclosure of one secret number on the other one in the pair is one of the channels that will drive the increase in disclosure. Finally, our last behavioral prediction about the sender was about the use of partial disclosure. According to the theory, partial disclosure should not be used in the data. However, we find that it's used more than 36% of the time, and that half of the observation in which partial disclosure is used sees a sender withholding a secret number that is greater than 1. So we do have evidence that senders engage in partial disclosure. Okay, now I promised you that we were looking at senders' belief and try to see how this rationalizes the behavior. What we ask subject in the data is to give us a distribution of belief over what they think is the guess that the sender will take after a certain disclosure choice. Given this distribution, we can compute on average what's the expected guess of the sender given a decision of not disclosing in the treatment, in the control, and a decision of not disclosing or partially disclosing in the treatment. To compute the number for partial disclosure, we pull all the cases in which partial disclosure is used. So the first thing that we see when we compute this number is that this expected guess after no disclosure, so when no information whatsoever is disclosed, is not different when we compare control and treatment. It's roughly 1.98 in both cases. So the belief of the sender are not significantly different in the two treatments when we only look at cases in which no information is revealed. Instead, when we compare what's the expected guess after no disclosure in the treatment and the expected guess after partial disclosure, again in the treatment, we find that the expected guess after partial disclosure is significantly smaller. And this difference is significant at the 1% level. We have a drop from 1.98 to 1.75. So this suggests that senders do believe that receiver will become more skeptical about the undisclosed information in the treatment, but this is true when they see partial disclosure. And this is consistent with what we saw in this previous slide of the disclosure probability of each secret number as a function of the other, because it justifies why we see more disclosure of a 2 when the second secret number is favorable, and less disclosure of a 3 when the other secret number is unfavorable. Okay, let me just spend now a few minutes on the receiver results. The first prediction that we had about receiver involved their behavior, and in particular, we conjectured that after no disclosure in the treatment, receiver would become more skeptical. So in this table that I show you, again, we treat each observation in the two numbers case as an independent one, and we compute what's the average guess of the receiver given the disclosure of each secret number and given no disclosure. Here we pull together both no disclosure and partial disclosure. We can see that on average, the guesses are correct when the secret number is disclosed. And instead, when there is no disclosure, guesses are higher than the maximally skeptical one, and they are also higher than the average value of undisclosed secret number in both treatments. More interestingly, though, we see that there is an increase in the average guess after no disclosure in the treatment compared to the control. And we can repeat the same analysis of looking at the average guess after undisclosed information by splitting in the treatment the case of no disclosure and partial disclosure. Again, we find that these two numbers are very similar between them, and they are higher than the average guess in the control treatment. So these results suggest that not only receivers don't become more skeptical in the treatment compared to the control, but if something, they become less skeptical about undisclosed information. And in particular, they don't take lower guesses in cases of partial disclosure, which instead, according to sender belief, should lead to extreme skepticism. So again, we can look at the player's belief, in this case, the receiver's belief, to understand why this behavior arises. And as before, we take the distribution of belief that we elicited in the data, and we compute what's the expected secret number from the receiver's perspective after no disclosure or partial disclosure. When we compare the two numbers in case of complete lack of disclosure in control and in the treatment, we find that the beliefs are less skeptical in the treatment, even if the significance is only at the 10% level. And then when instead we focus only at the treatment and we compare what's the expected secret number after no disclosure and partial disclosure, we find no significant difference between the two. So this, again, reinforces the fact that receivers tend to be less skeptical about undisclosed information in the treatment, and that partial disclosure does not trigger that increased skepticism that the sender conjectured. And now I'm basically out of time, but I just want to show one more result about the receiver, which is linked to this inability to account for the information contained in partial disclosure. So in the panels that you see on the slide, we plot what's the frequency of each guess that the receiver can take, so from 1 to 5, for undisclosed information in cases of partial disclosure when we condition on the secret number that has been disclosed. So for instance, this figure here, it's the frequency of the guess for the undisclosed secret number when the receiver sees a 1, and so on for all the secret numbers. And this is the one with no disclosure. What I want you to take away from this figure is that most of the mass of the guesses is on 2 and 3, which are close to the unconditional average. And in particular, the receivers tend to take guesses which are higher than the number that has been actually disclosed by the sender. So we see this as an evidence that receivers almost treat the disclosure choices of the two secret numbers as if they were strategically independent. Okay. So now let me just conclude. In this paper, we study how changes in the dimensionality of the information space affect the behavior of sender and receiver in a verifiable disclosure game. We find that senders disclose significantly more in the treatment compared to the control. And in particular, we find that the pair of secret number matter in the choice and that partial disclosure plays a key role in this increase in information. In addition, we find that senders become more skeptical about receiver guesses, mostly when there is partial disclosure. In contrast with these findings, we find that the behavior of the receiver is roughly the same in the two treatment, and the richer information structure does not improve the strategic inference that the sender make. Actually, that the receivers make. Actually, receivers seem to treat the disclosure choices of the sender as if they were strategically independent. And with this, I conclude. Thank you.